Our lesson today is going to focus on taking verbal expressions and representing them algebraically. And so we're going to be provided with a number of sentences, and we have to see how we can use the key words in order to represent these with an algebraic expression. And some of the key words that you're going to see are in this box here up at the top. So what I want you to do, I want you to match the words below to the correct symbol on your Words into Math sheet. Some of them represent addition, other words represent subtraction, some represent multiplication, division, some of them represent the equals, others represent parentheses words. So take a moment and let's see if we can match these words up with the correct symbol. So now that you've had an opportunity to match up the key words with the right symbol, we're going to go through and see if we can translate some of these expressions into algebra. And one important thing to notice is that we're always going to see a number in our sentences, like twice a number, 7 more than twice a number, okay, 5 and a number. When they're talking about a number, they don't tell you specifically what that number is. So when they say a number, we're going to use a variable to represent the number, again, since we don't know the specific number that they want us to use. Okay, so let's take a look at the first example. All right, it says twice a number increased by 15. And looking at this sentence, our key words are going to be twice and increased. And starting with twice a number, okay, means that I'm going to have to multiply some number by 2. And so since I don't know what that number is, I'm going to use a variable, and I like to use n when I'm doing this because a number starts with n. So to do twice a number, I'm going to write 2n, 2 times n. All right, and now if I'm going to increase that by 15, increased means I'm going to add. So I'm going to add 15 to the 2n. And this is the algebraic expression that represents twice a number increased by 15. In example 2, 7 more than twice a number. So again, our keywords here are more than and twice. Okay, and so if I want 7 more than something, I have to take 7 and I have to add it to something. More than means add. And again, twice a number, we just set up here, twice a number meant to multiply some number n by 2. So I'm just going to write 7 plus 2n to represent this expression. In example 3, 9 less than the product of 5 and a number, our keywords are less than and product. Now, 9 less than something means that I'm going to have to take something and subtract 9 from it. Okay, if you want to be 9 less than a number, you have to subtract 9 from that number, which means I'm not starting with 9. When I see less than, I'm going to have to do my algebra in the reverse order of my words. So I'm actually going to start with the product first. The product, that means to multiply 5 and a number, I'm going to do 5 times n. 5 times n represents the product of 5 and a number. And now if I want 9 less than that product, I'm going to subtract 9. Okay, so I'm going to put a little star next to this one. This is an important one to know. Less than, I'm going to switch around the order when I do my algebra, 5n minus 9. Very similarly, take 5 from the product of 4 and a number. All right, take from and then product. If I'm going to take 5 from something, well, again, I have to take 5. That means I have to subtract 5 from something else. So I'm going to reverse the order on this one as well. So I'm going to put a star next to this one. Take a number from something else, reverse the order. So let's start with the product. Product, again, means to multiply 4 and a number. So 4 times n. And now I'm going to take 5 away from that. So I'm going to have to subtract 5. When you take something from something else, you're going to have to reverse the order, just like we did in the third example when we saw less than. In example 5, 12 is subtracted from twice a number. If I'm going to take 12 away from something, well, again, I've got to switch my order and start with twice a number. As we review the number 1 and number 2, twice a number means to multiply your variable n by 2, so 2n. And now we'll subtract the 12 from that, minus 12. So there's the algebraic expression 2n minus 12 that represents 12 subtracted from twice a number. In example 6, twice a number is increased by 4, and then it is 25. Twice a number increased by 4 is 25. So again, twice a number means I'm going to multiply some number n by 2, so we'll have 2n. We're going to increase that by 4, which means we need to add 4. And now on this one, they say that that is 25. Is means equals, so this equals 25. This example shows an equation. Okay, twice a number increased by 4 is 25. In example 7, 3 times the sum of a number and 8. Okay, I'm going to multiply 3 by an entire sum. So let's start with the sum first. Sum means to add. All right, a number and 8. So some number n plus 8. Okay, there's my sum, n plus 8. I want to do 3 times that entire sum, which means I need to put the entire sum in parentheses. Okay, and then I'm going to multiply it by 3. 3 times the sum of a number and 8, I put n plus 8 in parentheses and multiply by 3. In example number 8, 15 more than the product of a number and 9. More than and product are the key words here. 15 more than something, so I'm going to have to take 15 and add it to something. 15 plus. Product again means to multiply a number and 9. So I'm going to do 9 times some number n. All right, my variable represents my number. The product of a number and 9 is 9n. 15 more than that, I'm going to add 15. 5 decreased by twice a number. Decreased by twice a number. Okay, so I'm starting with 5, and I'm decreasing it, so I'm going to subtract twice a number. 2 times n. 5 is being decreased by twice a number. The quotient of 3 in a number decreased by 2. Quotient and decreased are the key words here. Quotient represents division. Okay, so we're going to do the quotient of 3 in a number. When we show a division problem in algebra, we write it like a fraction. So I'm going to do the quotient. I'm going to divide 3 by a number. 3 divided by a number. And then if I decrease that by 2, I'm going to have to subtract 2. In number 11, we have 7 less than the product of 6 in a number. Well, again, less than. Put a star next to that. That's the same as in example number 3. When I had less than here, I had to switch the order. Okay, so I'm going to switch the order here. I'm going to do my product first. 6 in a number, that means 6 times n. And then to do 7 less than that, I have to subtract 7. So 7 less than the product of 6 in a number is 6n minus 7. In example 12, we want the number of students in a classroom that seats n students if 8 seats are empty. Okay, so the classroom will seat n total students. That's the total amount of students that you could have in the room, but 8 seats are empty. So in order to represent that, we're going to have to take our n seats and take away 8 because 8 of them are empty. That would show you how many students were in the class, n minus 8. In number 13, we want a club with W members if 10 new members join. So our club has W members, but we're going to get 10 new members, so we're going to have to take our current amount W and add 10 to that. In example 14, we want the number of pencils that Bobby has if Bobby has 3 more than 4 times as many pencils as Jill. Okay, well, we don't know how many pencils Jill has. Let's call that J. Okay, but we do know that Bobby has 3 more than 4 times that amount. So to do 3 more than 4 times that amount, we're going to have to take 3 and add 4 times the number of pencils Jill has, which we'll call J. So 3 plus 4J would represent the number of pencils that Bobby has. Okay, Bobby has 3 more than 4 times the number of pencils as Jill. In example 18, we're told that we have $25 saved, and we're going to save $4 more per week. So every week that goes by, we're going to save $8 more. So in part A, I want to write an expression for the total after 8 weeks. So I again was told that I already have $25 saved, so we're going to start with the $25. And then they tell me that I save $4 more each week. Okay, so after 1 week I would save $4 more, after 2 weeks I would save $8 more, after 3 weeks I would save $12 more. Well, after 8 weeks, okay, well, in order to figure that amount out, I would have to do 4 times 8, the number of weeks. I'm saving $4 for 8 weeks in a row, so I'll do 4 times 8. And now to get my total amount saved, I have to take the $25 I've already saved, plus the $4 more each week, and I'm going to have to add those numbers together. So 25 plus 4 times 8 represents how much money I would have after 8 weeks. In letter B, they want the expression for the total amount saved after 12 weeks. So again, we're starting with $25, and then we're saving an extra $4 every week for 12 weeks. So I'm just going to change my number of weeks from 8 up to 12 weeks. In letter C, they want an expression for your total savings after n weeks. Okay, so notice our number of weeks before was 8 weeks. Then we changed it to 12 weeks. But now we're going to use any number of weeks. So we're going to have the same expression that we've had previously, 25 plus 4 times the number of weeks, which in this case is just going to be n. I could use this expression to figure out how much money I would save after any number of weeks. N represents your number of weeks. In example 19, we're told that Marissa wants to buy a DVD player that costs $150. She already saved $25 and plans to save an additional $10 each week. So in part A, we're going to write an expression that represents the total amount of money Marissa has saved after any number of weeks. Okay, so we were told before that she's already saved $25, so let's start with $25. And we're told that she's going to save $10 each week. Okay, so in order to figure out how much that would be, we have to take our $10 and multiply it by any number of weeks. So let's use the variable n for that. Okay, n is going to represent our number of weeks. And now in order to figure out the total amount saved, all we're going to have to do is add these two together. She's got $25 currently, and she's going to save an extra $10 each week. N represents the number of weeks. So in part B, they want to know, will Marissa have saved enough money to buy the $150 DVD player in 11 weeks? So now we know in 11 weeks we want to be able to buy the DVD player. So let's take our expression from part A, 25 plus 10n. Okay, and again, in this expression up here, n equals the number of weeks. So all we're going to do to figure out if we have enough money is replace our number of weeks with 11. So our expression becomes 25 plus 10 times 11. Now let's evaluate this. I see addition and a multiplication problem. I'm going to have to multiply first. 10 times 11 is 110. So this is 25 plus 110. And when you add 25 and 110, you get $135. And so if the DVD player costs $150 and we've only saved $135, will Marissa have saved enough money? No. Marissa does not have enough money after 11 weeks. Okay, she can't buy the DVD player yet because she hasn't saved up enough money. She only has $135 and it costs $150 for the DVD player. Marissa only has $135.